HeliDirect!
Hi, I'm Nick Wisdom with Team Ego Drift, and welcome to the primer to what will be a pair of build videos coming soon. The first will be on the Goblin Raw 700 size helicopter here, and the second will be on the XL Power Spectre V2 you see on the shelf behind me. So, what is the primer video? So the last video I did was on essential workshop tools that you'll need to build your first kit heli. And this video will pick up where that left off with just a few of the extra pieces and parts you'll need, adhesives, thread lockers, a couple of supplies you'll need around the workshop before you can dig into your first build. So with that, let's get into it. The first thing I want to talk about is preparation. There are a few parts of a helicopter that we need to do just a couple quick initial steps to before we use them for assembly. One of the most common things, and usually the first thing I'll do once I've unpacked the kit, is prepare the side frames. So most helicopters are made from carbon fiber side frames connected in a variety of ways. And the thin, narrow edges of those side frames can have kind of a sharp edge. And this varies by manufacturer as to how sharp, but it's always a good idea to take some sandpaper. I generally like to use some small pieces of 400 grit sandpaper, and I wet sand the thin, narrow edge of the frames. Now, why do we do this? So dulling that edge from sharp to sort of a little more slightly rounded, you don't have to go crazy with the sandpaper. You know, just work it gently back and forth for a short term. Run your finger over it. If it feels smooth to your finger, you'll be fine. And we do this to protect the wires. So the wires from our speed controller, our servos, our receivers, will often run over the edge of the frame. And we'll talk about some techniques in another video about how to protect them. But to triply ensure that we don't let that sharp edge of the frame cut into the wire, we dull the edge with a little bit of sandpaper. Now, it's important to know, carbon fiber side frames, when you sand them, that dust is toxic. So do, if possible, do this outside, under a faucet or a hose even. Do it in a kitchen sink in a well-ventilated area while wearing a dust mask to protect yourself. The water, too, will help the dust sort of drop and, rinse out versus aerosolize into the air. So be careful. Use some 400 grit sandpaper and wet sand the edge of your side frames. This next tip is the single most important thing to do through every step of your helicopter to prepare it for a strong and successful life. So, helicopters are held together, the entire thing, with these metric hex head bolts. Now, when these are manufactured in the factory, some oils are used on the cutting tools that then get onto the screw, and also some oil is put on these during shipping just to protect them from rusting. And that oil will stop our thread lockers that we'll talk about in a minute from working. They don't allow the thread locker to properly bond to the threads and let it do its job. So we need to get that oil off. So how do we do that? So there are a variety of different ways to do this. And this you're going to find, and I'm sure you may see it in the comments section of this video. For every one way to do something in the hobby, there may be 2 or 3 other ways, or different chemicals, or different products, or people that like to do it one way or the other. No way is necessarily better than the other. The important thing is that you do it. I like to use acetone to clean all of my screws, and I'll show you how I do it in just a second. This is available in most home improvement centers, paint stores. It's often used for cleaning paintbrushes and similar paint sprayers, things like that. So, take some common paper towel, take a small piece off, and then I like to fold it into about square shape. And I just tip the can over, peel the paper towel away a little bit, you get a nice damp spot on the paper towel. Take your screw, take your hex driver, and you just take the wet part of the paper towel, fold it around the screw, and we're just going to rotate the screw. And I'm pinching the threads nice and tight as I spin the screw in the paper towel. I'm going to move it to another spot, and I'm going to do it again. Spin it, pinching nice and hard, really pushing that acetone into the threads. And what do you get? You see that residue on the paper towel? That's all oil we just pulled off of that, right? That will stop your thread locker from working. It's extremely important that you go through the effort to do this with every single bolt used in your helicopter. If you don't, the thread locker will not work. The vibration in a helicopter from the rotating parts will let this bolt back out. And obviously you don't need to use your imagination much to realize what will happen. So cleaning every single bolt, it should be part of every step. You don't want to do them all and then start your build, but generally as you start a step, you pull out the pieces you need, clean them, set them aside, and then do that assembly step. You just need to let the acetone burn off for a short period of time. Usually by the time you get to the last bolt that you need to clean, the first ones you did are ready to go and ready for thread locker. You don't have to let them sit for very long, just a couple of minutes, and they're ready to go. So do clean every single one of your bolts. If that's the only thing you take from this video, I'll be happy. So the next thing we're going to talk about briefly are lubricants. You will need a couple of different varieties of those for your helicopter builds. The first is grease for the main rotor head. I like to use Tri-Flow synthetic grease in my main rotor heads. What do we use this for? So we put it around the thrust bearings, on the dampeners in the head, all of the moving parts inside the main rotor head of a helicopter and in the tail rotor. It's important to use grease. This is a clear synthetic grease made by Tri-Flow, as I said. Works great for me. You're going to find when it comes to lubricants that there are a lot of varying and disagreeing opinions in the hobby about this. No one way is right, although everyone will tell you it is. But it is important in the main rotor head to use a clear synthetic grease. Now, the other variety that I use is a Tri-Flow liquid type lubricant. This I use on the one-way bearings in a helicopter. It's important not to use grease in one-way bearings. It sort of gums up the works, but a bunch of this literally applied inside the one-way bearing will keep it operating for a very long time. Some folks like to lubricate the main shaft as well as the tail rotor shaft where the pitch slider moves back and forth along it with a little bit of Tri-Flow as well. It's important, in my opinion, to not lubricate any bearings in a helicopter. There's lubrication already inside them, and adding more actually rinses that away. So don't put this in the bearings on the main shaft and in other places. Don't create places to add lubricant. Most good quality helicopter build manuals will tell you exactly where to apply grease or lubricants and which types, so follow the manufacturer's advice carefully. There are a couple of other ones, dry lubes, as well as another one that some folks like to use. This is one of those areas of the hobby where if you ask 30 different people, you'll probably get 20 different versions of this. They all follow common themes, but everyone has their favorite lubricants. Everybody swears by one over another, whether it's marine grade or a particular brand. Follow the manufacturer's instructions. Use them in all the right places, importantly in the main rotor head and tail rotor. And don't put them anywhere they shouldn't. Don't lubricate bearings that are already lubricated. You'll rinse that lubricant away. All right, next up, we're going to talk briefly about adhesives that are nice to have around the workshop for a build. This is a cyanocrylate or superglue type adhesive, as well as an accelerant or a kicker, which when you spray this on it, it sets instantly. Generally, we don't use a lot of CA in radio control helicopter builds. Sometimes if there's protective edging you have to install around the edge of a canopy, you might want some thin CA for that. Not a lot of other uses for it, but it is kind of nice to have around the workshop. You never know. What we do use is a epoxy or JB weld, which are different types of slow curing adhesives. I like to keep 30-minute epoxy around. This is a two-part adhesive. You mix these together in equal quantities, and then you have about 30 minutes of working time, meaning you can apply this epoxy, and it's pliable. You can move it around and work it into a surface. And then in about 30 minutes, you got to leave it alone and let it set. What do we use this for? So generally, if we are building the push rods out, so we're adding the ball link ends to the end of a carbon fiber push rod, we'll scuff the end of the push rod up, we'll coat it in epoxy, we'll slide that ball link over the end. The same is true of the boom support rods. We'll epoxy those ends on as well. So follow the manufacturer's instructions as to length and epoxy those on. So some 30-minute epoxy, always handy to have around. Alright, one of the last pieces you'll need when building a helicopter is a place to do so. What's the ideal spot to build a helicopter? Well, obviously a large flat table or surface. Here in the workshop, I've got a rolling work table that I tend to build my helis on. But a hard flat surface does really good at little screws bouncing off and rolling onto the floor, never to be seen again. So for the most part, we like to put down a build mat. This right here is an example of a silicone build mat. They're available for a variety of hobby and craft uses. This is just nothing more than a silicone mat. It's got a little bit of a raised edge. The nice thing about these is that if you do happen to drop a screw on them, it deadens the fall. They don't bounce very far, so they tend to sort of stay on the mat. It's got these little compartments down the side of it here where you can place different screws. So as you open a packet, most of the screws, nuts, and bolts in RC helicopter kit come in these small little baggies. You can sort of put the parts for the step you're working on in these various little compartments. And the mat gives you a nice place to do it. If you spill Loctite on it or whatnot, it's no big deal. The silicone mats, you can literally put them in the top rack of the dishwasher to clean them, or just use hot water and some mild soap. So having a great place to do it. There's also a sort of build mats, they're called, that are available from most hobby shops. It's really just sort of a silicone woven towel, kind of like what you might see in one of your kitchen cabinets that stops the glasses from slipping around, same kind of thing. In fact, you can even use that material for a really cheap version of this, or you can buy branded ones with the logo of your favorite motor, ESC electronics, helicopter brands, etc. So make sure you've got a nice flat level surface, plenty of good light, and a nice build mat to hold the little pieces and parts. At the very least, some bowls, little Tupperware containers are handy to have around for screws, nuts, and bolts and things. One more thing that's nice to have to help you out along the way with a build is a set of digital calipers. These are nothing more than a measurement device with a digital display that tells you in metric or standard the distance that the jaws are apart, and it's got a set for outside measurements and inside measurements depending on where you're going. So you close it all the way. There's usually a button that says 0, so that just zeroes the measurement out, and now as you slide this to measure things, it will tell you on the display the distance, in my case, millimeters. Most helicopter parts are in the metric system, so it's good to get used to that. Why is this handy? In one package of hardware for a certain step, you might have 4, 6, and 8 millimeter long bolts. If they all get mixed up in a pile and you pull one out, you might want to make sure you've got the 8 millimeter. You can just grab it in here, throw it in, make sure it's the 8. Another time you'll use it a lot is building linkages. So for the swash linkages, you may need 3 38 millimeter linkages. So the manual will dictate what that length is. So you set your calipers to 38 precisely. Just gonna get that right, or as close to thereabouts. And then there's usually something you can tighten down, it will vary on the caliper, that'll hold it. So now I've got these calipers locked in and set at 38 millimeters. So now I can build a linkage, stick it between these jaws, make sure it's the right length, put it down. Build the second linkage. Set it between these jaws, make sure it's the same exact length, put it down. Build a third linkage and set it down right here. Then I'll have 3 precisely the same length linkages for the heli. So set of calipers, super handy for making sure you have the right hardware, for getting things set to the exact same length, measuring a variety of things, wires, lengths, whatever you need. Super handy tool to have in the workshop at your side when you start your builds. Last but not least, we're going to talk about thread lockers. Now, I talked a little bit about this in my last video, but I want to talk a little bit about it in more detail here. So, thread lock is a type of adhesive, in a way, that creates friction between metal parts that stops them from being able to separate or rotate apart due to the vibration that occurs in radio control helicopters. The most common one we use is blue Loctite. Loctite is actually the manufacturer or brand. Thread locking compound is generally what they're referred to as globally. But Loctite brand, there's a lot of other good brands too. SAB makes some great thread lockers, as well as several others. Just make sure you use a reputable brand. So blue Loctite is sort of the bread and butter, heart and soul of our helicopters. There's a lot of metal-to-metal connections that require using Loctite on. Never use Loctite on a metal-to-plastic connection. If you've got a nylon lock nut, you don't want to use thread locker there. Why is that? Thread locker actually weakens plastics. So you'll create a problem where the metal, the plastic in the lock nut, may actually fracture or break. So it's only for use on metal-to-metal connections. So how do we use this? Well, I like to take a little piece of paper towel, or sometimes just one of the plastic baggy wrappers from inside the kit, and I'll lay it out. I'll take my Loctite and I'll just put a little dab of it, just a drop on there. All right, so we've got a drop on there. I'm going to take my bolt and I'm just going to roll it in the paper towel and get some on there. You don't want a ton on the bolt. And then I'm going to take my fingertip and roll it. What that's going to do, it's going to push some of the Loctite inside those threads, take a lot of it off back on my finger, which you then wipe on the paper towel you've got there. So I've just got some on the tip of this bolt. Grab your driver and set it home. Don't need a lot there. Metal to metal, those are the key things to remember. Make sure, again, as we talked about it a minute ago, before you apply any Loctite, you've cleaned your screw with acetone, alcohol, something similar as well. Get all that oil off from the machining process before you apply a Loctite. So, what other types of Loctite are there that we use? This is red Loctite. The difference between red and blue is red has a stronger grip than the blue. Blue's not weak by any means, but red is semi-permanent. What do I mean by semi? Blue Loctite, enough pressure, you'll hear a little pop when you get the screw to release from the Loctite, and you can back it out by hand. Red Loctite, you generally have to add some heat, which will weaken the thread locker, the red thread lock, and allow you to mechanically remove the screw. Without heat, red Loctite is much harder to break. You run a much larger risk of stripping the screw, etc. We use this for mission critical screws. I know just about every screw in a helicopter is mission critical, but some are a little more mission critical. So the balls that you screw into the swash plate that your servo link arms are connected to, you don't want those backing on you. Red Loctite for that. Motor pinions, the pinion screw and a tail pulley. These are extremely important. You don't want them backing out, and especially on a small grub screw or set screw in a pinion, there's not a lot of surface area contact there to stop that little screw from backing out. So you really want to make sure you lock it in with red Loctite. This is, again, one of those areas of a helicopter where folks will have some differing opinions of where you should use red and blue. But most folks agree, swash balls, if you have a servo ball into a metal servo arm, again, metal to metal, same is true of red Loctite. All of those mission critical screws, pinion screws, make sure you lock them in with red Loctite. And then last but not least is green Loctite, which is actually a retaining compound. We use this for bearings in some places, and again, the helicopter's manual will be the best place to decide whether you need green Loctite on a bearing. Some locations the bearing's really trapped, it can't move or fall out or go one way or the other, so you don't really need this. But let's say you have a main bearing block and a bearing that's just a press fit in there. You put a tiny bit of green Loctite just on the outside of the bearing, again, being really careful not to get it inside the bearing at all or in any of the moving parts, because it will gum it up. And it'll seize. And all this does is once it sets, it traps that bearing in the metal to metal bearing block, right? That connection, it's glued in essentially with green Loctite. We don't use this in a lot of places on a helicopter, but generally bearings and bearing blocks, a little bit of green Loctite goes a long way there. There are some radial bearings in the main rotor head of a helicopter where the manual will ask for a little bit of green Loctite, so have that around. So red, green, and blue Loctite, all great to have on hand. With that, those are really the essentials we need to get our helicopter build started. The next video you see from me will be the start of either the Goblin Raw or the Spectre V2. Happy building. Now that we got all the pieces and parts, let's get into the builds.